Here we are back on part 2, and we're wondering, with the sun providing the centripetal force to cause Mars to go in a circular path, how fast does Mars go? Well, we actually have all the tools to do this problem, and so let me show you how to do this one, and then I'll probably do 2 others and then ask you to do a couple. And that'll be the end of our class. So let's see how it works. Well, we know that force centripetal, and anything I write down on this paper you write down as well. We know force centripetal is mv squared over r. But what is the centripetal force? Well, it is gravity. So I'm going to grab gravity right here. So it's going to be gm1 m2 over r squared. All right, mathematically, when I set these two equal, I have an equation which I can simplify. And I notice this is m1, m2. I'm going to kind of change that mass 1 and mass 2. And there's 2 masses. One's in the center, so I'll say the one in the center for C. And the one is orbiting around, so I'll say O for orbiting around. Over here, which one of these is represented on this side? You have to know whether this one is the one that's in the center or the one that's orbiting. This is the orbiting mass as well as this one. So mathematically, if the m orbiting appears once on each side, I can cancel them out by division. So now I can simplify. If I multiply both equations, now these m's of orbitings are gone. I'm going to multiply both sides of the equation by r squared. When I do that over here, the r squares cancel. It leaves me g and the mass in the center equals, and over here one of these r's will cancel one of these r's, but there'll be an r in the numerator now, and v squared. So this will be a good starting point. When I forget this, I always go back to this because I can remember the force of gravity and the force centripetal. I can set them equal and simplify just like we've done. But if I can remember, I start here. It saves me a couple steps on these problems. So my question again is, how fast does Mars go? So that's going to be our velocity. That's what I'm going to look for. So I should find a value for everything else. So when I'm doing this problem, g is 6.67 times 10 to the, do you recall? Have you been well taught? 6.67 times 10 to the minus 11. Then the mass of the sun is something that is known, so I'm going to grab that from a chart somewhere. 2.0 times 10 to the 30. So I'm going to assume that it can be used in this problem. The radius of Mars is its distance from here. We call it the orbiting radius, so it will include from center of Mars to the center of the sun, r. So that is also known. It can be given to us. I'll put r first. R is 2.3 times 10 to the 11th. So when you do these problems, they'll start with some given. So these would be given, and then v squared is what we're looking for. Mathematically, we're going to divide both sides by 2.3 times 10 to the 11th. And whatever answer this is v squared. I'll square root that to get v. So when you tapped it in, you do 6.67 EE, which is second, what was it? I forget, comma? I think a second comma, negative 11 will save you a couple of keystrokes, times 2.0, second comma, which is E 30, and then hit enter. Then hit divide and 2.3 EE 11. Then whatever's on your screen, you take the square root of that. When you do that, you get 2.4 times 10 to the 4th. Since it's a velocity, it is in meters per second. So our masses will be in kilograms and our velocities in meters per second. All right, let's see if we can do another one. So again, if this is your starting point for them, I think that you just follow what is given, what's not given. Just follow your mathematical nose and it'll lead to the answer. All right, let's see what the next one is. We will find Mars' period of rotation. So that means the time for it to go around once in its orbit. So let's work on that. So once again, we're going to start from that same starting point with that simplified version. G, mass of the thing in the center, equals radius v squared. And this time I'm looking for t. Well, I don't see time. I don't see period, like a time of any kind there. So this is going to help me, but when I do this kind of problem, I want to know that time, or period, which is time, it's measured in time, is distance divided by velocity. Now the distance is going to be, the distance is the path around. So Mars is going around. We have a picture up here. Mars is going around. So the distance is how far it is around in one cycle. So the distance around wasn't given. So we'll have to do a 2 pi r. And when we get to r, the radius was given. Up here we actually used it right there. So it was 2.3 times 10 to the 11th. And we will divide by the velocity. But the velocity was calculated in the problem before. Remember the question was how fast was Mars going? So we can go back there and grab that number, 2.4 times 10 to the 4th. All right, I'll be right back.